Awesome. Well, welcome everyone to this software carbon intensity workshop, and welcome everyone who's online as well, playing along at home. I put a link to this workshop deck as well that you can access at bit.ly/SCI workshop. So if you want to look at the deck at home or here, you can to refer back to it. So what's on the agenda for today? So the first bit of the session is going to be a bit more presentation, but I'm really here to answer questions as well. So feel free to put questions in the chat. Cam is monitoring the chat for us, and if anyone here wants to ask questions as we go, please interrupt. It's more than possible. So we'll go through what is the software carbon intensity standard from the Green Software Foundation. Then we're going to walk through some sort of example software applications that then in the second half of the session, we're going to break out into small breakout groups or small teams to sort of attempt to apply the SCI standard to those example software architectures and maybe learn throughout that process. And then do a bit of group sharebacks, and then finally do a quick little debrief on how the session itself went and see if there's any feedback anyone has. So just to set a bit of context for why we're sort of talking about the software carbon intensity standard, you don't need to be sort of an expert in what the greenhouse gas protocol is, but it's a common framework used to account for carbon emissions across an organisation or business. And earlier today, we heard people speak about Scope 1, Scope 2, Scope 3 as part of the greenhouse gas protocol. But there's some problems with applying the GHG protocol when it comes to software. So firstly, greenhouse gas protocol is sort of really used to account for carbon emissions from different business units, let's say finance, operations, product, engineering teams. But software itself sort of exists beyond and outside of those organizational boundaries. Let's take the Windows operating system. You know, Microsoft developed that operating system, but it exists well beyond the borders of Microsoft as an organization and consumed by millions of people around the world. Also, what about open source projects? How does that fit in with consumers of open source and the greenhouse gas protocol? It becomes challenging. Another aspect of the GHG protocol is that it's sort of backwards looking and focused on sort of accounting for carbon retroactively, I suppose, you know, carbon emissions, and doesn't really think so much about what reductions are possible. And with the Green Software Foundation, we're really trying to reduce the carbon emissions and other aspects associated with software. And then lastly, GHG doesn't factor in organizational growth and feedback loops quite effectively because it's often done on an annual basis, and then you have strategic plans to try and make changes to that. It's slow and there's a lack of tight feedback loop. So, and how do you know if your plans are actually working if you're only accounting for stuff on a 12-month basis or maybe quarterly? Yeah, absolutely. So that's where the SCI sort of came about, in that it's a rate of carbon emissions, not a total, and it's biased towards action that eliminates carbon emissions. And we're hoping that the equation is somewhat simple and elegant to a very complex problem. So this is a summary of the SCI at a high level. We'll talk through each of the components individually. So firstly, the energy consumed by software in kilowatt hours. So whether that's software running on a mobile device or in the cloud or on-prem, there is energy required to power that software. So energy consumed. I is the carbon emitted per kilowatt hour of energy in grams of CO2 per kilowatt hour. So another way we often talk about this is emissions factors for that energy we're consumed. We then add in embodied carbon emissions from the creation and destruction of hardware that the software is running on. So let's say a cloud provider builds a new data center. There are carbon emissions associated with finding the raw materials and transporting those materials and actually creating the server racks that are in that data center. So we want to take that into account as well. Then lastly, per R, which we hope makes the specification a little bit more valuable, is a functional unit. So, and this is really focused on how your software scales. So is it by user, by number of device, by maybe a certain number of API requests? This functional unit is for organizations to define for them internally, so you can then track and measure your progress over time. So this is like a really important component that's meant to incentivize reduction of carbon emissions based on how your software scales. Does anyone have any questions, or are there any questions in the chat at all? No? Any questions at all? Yeah.
So carbon emitted, is that, does that help take into account like hourly emissions? Like could that be incorporated over time?
That's a really great question. So when it comes to the emissions factors, something that I didn't actually specify in this slide, which I probably should have called out, is that we're looking for a marginal emissions factor, which is different from a consequential emissions factor. So marginal emissions factor takes into account the supply and demands of energy in a particular given market, that if you did or didn't use that amount of energy, what are the overall impacts of your consumption of that energy, rather than just the energy, the carbon associated with your particular consumption. It basically takes into account grid supply and demand factors as well. We've got more documentation on that that we can follow up on, and the granularity of that, we specify that you at least need to use annual averages for I, but we recommend that you use far more granular, so daily or hourly, when you have that data available. Yeah.
So how do you calculate the energy consumed by software? Do you need a standardized hardware to test that? Because I would assume that software running on different hardware can generate different results.
Totally true. So there's generally two categories of the way that you might come up with the E, the energy consumption. We're actually not going to go into how to do that in this workshop, but just to speak to it, there's either measured energy consumption. So there's a number of open source projects that exist that allow you to use open source tools to measure, let's say, bare metal hosts on bare metal Linux hosts that you have in a cloud provider. And there's been some open data published around that, which is actually so measured energy consumption, whether it's on-prem or in the cloud. There is some open data on that. The other way you go about it is to estimate or model what you think the energy consumption is likely to be. So that's where we talked about Cloud Joules earlier today, Thoughtworks Cloud Carbon Footprint. That takes a sort of modeling or estimation approach based on coefficients and our understanding of cloud providers' infrastructure. So both, I think, are equally relevant, and maybe a combination of both is like a good way to go, where you have some access to metered or measured energy consumption, and then part of it might be modeled. I haven't seen the measured approach be holistic and scalable from many software applications, but I think as we develop more and more, we're going to have more of that data available. Awesome. So just real quickly, so what's the intended use for the software carbon intensity standard? So pretty simple, we write or use software, but then we want to measure the software carbon intensity of that software that's written or used. But then clearly we want to take action. This is the thing we want to really bias towards, is action to reduce carbon emissions. So just at a high level, some of the categories that we can look into here. Energy efficiency, so take actions that reduce the electricity software used to perform the same function. One thing I find interesting in this topic is that oftentimes as engineers we think that performance improvements will also mean energy improvements. Actually, the opposite effect can occur. When you optimize for software performance, it can actually increase the amount of energy that's being used. So that's like a really interesting sort of trade-off, and that's where measuring the energy usage approach is important to consider. And hardware efficiency. So this is also a really interesting topic in that more modern processors are generally more energy, consume less energy than previous processors to do the same amount of compute workloads, generally true. However, if you look at the whole life cycle of servers, if you're constantly deciding to go for the newer and newer services, you're not allowing the older servers to have a longer life cycle, which means the embodied emissions from those servers, you're actually creating more embodied emissions. So there's a bit of a trade-off there when it comes to hardware usage and hardware efficiency. And lastly, carbon awareness. So this is all about looking at the place in the world that your software is running and the time in the day that your software is running to make sure it's leveraging cleaner, more renewable energy. Google have done some really good work on the topic of carbon awareness, and I believe has started even to think about baking in carbon awareness into some of their tools. They've got some really good papers on this, and the Green Software Foundation is actually working on an open source tool called the Carbon Aware Sdk that's going to be able to integrate into your build pipeline, starting with GitHub Actions and other common CI/CD pipelines to allow you to deploy your software in a location and at a time that consumes the most renewable energy in an automated way. So stay tuned for that open source project. Any other questions at this point? Cameron, any in the chat at all?
Nope.
Cool. Okay, so in this next part, we want to, we're going to talk through 3 example software applications that we've pulled together some example data for you, and we're hoping in small groups or individually, if you want, just to try to apply the SCI standard. And so we'll just talk through the example software application first. So this is the most simple. And you can see a link there to for each of 3 of these, we've got a link to the data sheet. So if you go to bit.ly/SCI example 1, it'll pull up a Google Doc that you can then look at the data for. But this is a very simple software application. It's just an API deployed to an instance in the cloud running in a US East region, and then there's some data going back and forth between that. Right. And you'll see more data on this in the data sheet. The next one is sort of medium complexity. So very similar URL. Basically, instead of a single instance of an API running in one region, we've got 2 instances running in US East and US West. We've introduced a database behind that, and also an application load balancer as well. And then lastly, the most complex, this introduces the concept of 1,000 mobile devices that are consuming data from that application. So everything else is exactly the same. And this example, you'll see in the title, we wanted to call out embodied emissions, so M in the equation. If you do look at this example, this is an example where we'd love you to look at the data sheet with regards to embodied emissions from the mobile devices that are being used as part of the application stack. So just wanted to call that out. Yeah, Cam.
Got a question in the chat.
Yep.
How do we account for the emissions that occur moving the request and response through the internet?
So that would be data traveled, certain amounts of data traveling over the internet, whether it's from like a mobile client to an API or something. For the purpose of this exercise, we're actually going to give you what the energy usage is from that, so you don't need to calculate it. But in the real world, if you're going to try to quantify data traveled over the internet, it's actually a really tough problem that we've been looking at for quite some time. There's been a lot of research in the past that has shown really large numbers of carbon emissions associated with that data, and increasingly research has been showing it less and less and less based on how IP, internet service provider ISPs like build and maintain those networks. More recently, I've seen strong arguments to say that the amount of data that's traveled across the internet actually doesn't affect the amount of carbon emissions from that usage, and I can potentially follow up with some of that research that we've seen. So in the case here, we're just going to give you the figures for the energy usage, but in the real world, it's a really tough problem about internet data traffic. Thanks, Cam. Any other? No?
Good.
All right. So just a bit of guidance for the next, where are we at? Oh, we're only at 1:16. Okay. Well ahead of time. So for the next like 25 minutes or so, we might finish a bit early. We're going to do small breakout groups for those online, probably in groups of 3. And then if the folks here physically want to break out into small teams or individually, what we wanted to do is try to use the data sheets provided in the links and try your best at calculating what could that SCI be, factoring in the elements that we looked at before, and also deciding on what the functional unit, or R, might be in that case. So just a couple of notes on this. All data provided for the in those data sheets for the example is example data, and it's just used for the purpose of facilitating the workshop. There are actual data sources for some of these things, but we wanted to just keep things simple for everyone. Also advise, start with the most simple, and then if you feel like you've got some good numbers for the most simple, move to a more complex example after that, just so you can start to sort of get increasingly complex as you go. There's also no right or wrong. Please interpret the examples as you want. Discussion debate is encouraged. There might be things we've missed in some of those diagrams or some of those examples. Also, and feel free to consider potential factors not included in the examples. And also, if you really want, you're welcome to use your own software to calculate the SCI rather than the examples provided. And if you need help or support, there is once we do the breakout rooms in Zoom, there is a button that you can click that says get help, and myself or Cam will be able to drop into your Zoom breakout room to help and support you if needed. Yeah, so we'll give 25 minutes for folks to take your time, read through the data sheets that were provided. If you have questions and you're online, use the help button. If you have questions here, we're here to help. Does anyone have any questions at all before we do the breakout rooms? No questions coming up, Cam? Okay. All right, I'm going to do the breakout rooms. How many people do we have, Cam?
There's 20.
20.
Some may be idle. I'm not entirely sure, but
Okay.
there's at least, I'd say, half that active.
Half that? Okay, so maybe we'll do 3 breakout rooms. We'll do 4 breakout rooms. We'll see how that goes.
We can pop in and monitor, see.
Yeah.
Also, I think you may have said this, but totally optional to join.
Oh yeah, I forgot to say that. The breakout rooms are totally optional. If you're online and want to just do the exercise yourself and without doing it in small teams, that's totally fine as well. Okay, I'm going to open the rooms.
There are also other design practices that you can use, right? Model, triggering
cool.
action, variable reward, testing here. So this is good, which we're kind of getting techniques that are repetitive to practice in the repetitive process of again triggering that thinking and then having them take action to do that sustainable behavior and then giving them some type of variable reward while doing so. So you may have seen this and
Are we muted?
My start video here is that no, it's the wrong one. Yeah, I didn't want to accidentally on video.
Yes. Okay. You are too? Yeah, I have.
Yeah, cool.
Oh, nice. Okay. Yeah,
I
it's
don't
funny
know why I
that
thought you were.
Oh, really? Elizabeth. Yeah. Weren't you West Coast?
I was.
Okay, cool.
I moved.
I was like, I could have sworn.
Is Elizabeth here? But she's
Yeah, she's here. She's in the workshop.
Oh, nice. Okay.
Yeah.
Did she fly in?
I think she was already here. Yeah, it's Carol's back together.
So
I know.
see her. That's the.
Oh,
Yeah,
nice.
yeah.
Ah, I
So
wish I would
it
run
was-
into you.
Oh, were you there?
Yeah.
Awesome. Right, I think we're all back from the breakout groups. Just wanted to open. Let me get my slide deck up. Just wanted to now take a bit of time to just to share back and have a bit of a discussion about how, what was some challenges, insights. Any sort of thoughts. Folks who are online, if you want to put any comments or insights or questions in the chat, feel free, and then we can sort of discuss them here. I know we don't have an ability to unmic people, unfortunately. So if you could put any thoughts you have in the chat, that would be really helpful. Anyway, anyone want to dive in with any thoughts on how that experience was, sort of what was challenging or insightful at all?
Yeah, I think for this group, the local group, sorry, for the online
fine.
people if you
Yeah.
can't hear me, but the EI part came relatively easy, even in the later ones, and then it was like the normalizing M per R, and also like getting it on the same level of time, because like M doesn't really come like per month.
Right.
It's just effective CO2. So yeah, just that was one thing that tripped us up. Oh yeah, we did that too.
So one discussion we had was about which percent to account for US East and West, the example 2 and 3, example 3, since you used one of the two. Yeah, that was quite deliberate. We were trying to be less clear about which region to choose for some of the components.
We just used an average.
Use the
Like that,
average? Yeah. Other than M, was it the M stuff? Was there anything else that was challenging at all?
Like getting the intensity of mobile applications.
Sorry, I was reading the chat. The message came up.
No, getting the intensity for the mobile application.
Right. Yeah. Do you have any feedback on the specification itself, or any ways that it could be better utilized or improved or anything? Because this is the alpha version, by the way.
Cool.
It's like, we haven't even hit the V1 yet, so it's like very new. It was just published a few months ago.
I think giving people examples of calculations.
Yeah.
What you're doing. And like pointing out areas of uncertainty and like decisions that will have to be made, such as like how much time is reserved, how much. I don't think there's anything. I liked your question, like in the dash, like what are the boundaries that you draw?
Yep.
And are there things it doesn't capture?
Yeah, one of the other open source projects that's kicked off it's called the Sci Open Ontology project. All these projects I've mentioned, by the way, are publicly accessible on GitHub. There you can submit pull requests if you want. But that project is all about solving the software boundary question by coming up with an ontology framework that is consistent across all use cases. So you can it basically creates a library that you can use, and then once being one of the sort of library of components and things that the team wants to try to automate the process. So like command line utilities define what your software boundary would be, and like auto-generate like even a visual representation of what your software boundary should be. So that's going to be a cool project as well.
It's more of please scroll kind of side of it. Please just use the top.
Yeah, Sebastian, that's the same what the group did here. When they didn't specify the region, place the average and hopefully that's what the average did here.
It's one of those things that come at hand. And then I don't know, I mean, most of you are in North America, when you do where to access the website.
All right, well, any other thoughts at all on that exercise?
It was a cool escalation to see at the end that the
Okay.
mobile usage, like, it was the lion's share of the impact.
Right.
That's very
Yeah, that was shock and awful.
What was?
I said that was shock and awful, to see the impact of mobile.
Yeah, the impact of mobile devices. Yeah, sure. Well, that kind of leads into the final section where just wanted. This is only the second time that I've done this workshop. I did it once internally with some thought workers. And I always think it's helpful if there's any feedback or any ways that we can, what went well, what could improve. So folks, feel free to put, basically what I was thinking, like if we could just take like 2 minutes now just to think about things that were useful in the workshop, and then maybe 1 or 2 things that would be improved, and then if you can share, that would be really helpful. So just take 2 minutes now.
I think okay.
I was giving people to think because yeah, just take 2 minutes to think about it. Maybe write it down. Yeah.
What I can tell you though, just as first,
By the client workshop.
one of the things that is important to note, and I'm mentioning it just because you showed up in our European session earlier today where someone asked this particular question, which is that, well, what happens if I post my website? There is standard low energy, like standard energy, just because to me. And again, it's one of those reasons why I think that's higher.
All right, let's open it up maybe. Emily, I know you might have had it.
Oh, sure. Yeah, I was going to say, in addition to increasing the complexity of the system, it would also be cool to start adding a little bit more into how to calculate energy.
Yep.
Step people through that.
As you go. Yep. That's good. So because example 1 and 2 are kind of the same.
Yeah.
Like the mental process is very similar. Those are just additional.
Yep.
So like making it a bit more, giving less, like giving more of the input data for the second example.
Exactly.
Oh yeah.
Yeah. Yeah. Like input factors into energy intensity.
Yeah. Rather than just
and
giving
even
it away.
Links to such sources, links to resources to calculate these.
Yeah.
Near side so again, it's one of those things that people.
Yeah. Anything else that could be improved or went well or anything at all?
Maybe an answer sheet to reference. I know.
Oh, that's a good suggestion.
Yeah, and I know it's up for discussion, and it won't be exactly 1624 grams carbon, but every time, but
Right, it's true. It'd be good to know, were you in the right ballpark? Yeah, that's good feedback.
And also, like a breakdown answer, not just
Or
the
like
number.
an example of how you would do the calculation. Yeah, that's really helpful. And has different formula based on reasons. Yep. That's really good feedback. I like that idea. Awesome. Well, unless anyone has any other final thoughts or anything, we can wrap up a little bit early. And I just want to say I really appreciate you attending and engaging and giving feedback on both the standard itself, because that's valuable for the foundation, and this workshop, as an asset.
Yeah, thank you.
Thanks, Dan. This is great.
No worries. Thank you.
This is really cool. It's SCI.
And thank you, Brian. I agree that there's probably no correct answer, but could walk through an example of doing one of the more complex calculations with the whole group at the end to talk about trade-offs. That's a really good idea,
that's
actually.
a really good idea.
Because we have a bit of extra time. It would be good to walk through the trade-offs and challenges. Great idea, Brian. Really appreciate it. Got some really good optimizations. Finally, if you have further feedback, feel free to email me. Really appreciate it. So, yeah, I think that wraps us up.
Great.
Thank you. Sure whether to turn the meeting on.
Alright, if you have time, it was a little hard to hear that last audience comment. So if you have time to just give a quick summary, but if not, okay, I know you're one.
Sure, sorry. I was only commenting on the fact that 90, not best practices, but it was just one non-sustainable use. And I was commenting on the fact that this moment in time, it was very difficult to actually manage that and know
Sorry. Not stationary.
Summarize